Yeah.
No. We're about to begin over here.
Okay, Southbound plugins. Let me get them.
Alright, good one. It's fine.
Because this is scaling the system.
What is your... I was expecting
One server.
any model it's exactly the same. This is all plugin on the cell exactly the same as the exact same thing. What makes it a solo plugin or not are those interfaces that really makes it a solo plugin. Right. Now let's take an example of protocol plugins over
It doesn't make a difference. If you show me what needs to happen.
So one of the very first things that really makes it a plugin or any module is activated in Java. If you look at activated in Java, this typically is an internal process. The activator is volume support again. So let's start from implementations. So we have two functions called get implementations and configure implementations. These two functions expose what a given module does, and what it depends on, what it exposes. Right? Now, implementations are those class files which directly interact with other class files or other modules. Topology service here, we see a corresponding topology service in configurations, so on and so forth. Now, we see that topology service is a class inside OpenFlow plugin which exposes I plugin topology service and I topology service insertion is listening. So, when you go to the board and explain a small thing, then you make it what each it's fine, it's not okay.
I can handle that. I can handle that. Yeah. I'm not saying that.
Okay. So, SAL is very thin. SAL is in fact SAL has no implementation. SAL provides APIs on both the northbound and southbound. So SAL is a very thin medium. So whenever you see in every service, today SAL provides 6 services. Now I need to go more. So we will be 8 services. First, like the service.
Yeah. I'll defer.
Discovery service. Topology service. Program service. Any model lying on top, we call it application. The FRM application. The topology manager is the UI application. So on. All these applications involve all top this service, which is the out. So every plugin, every service will have two interfaces. An out interface, so you see I plugin out, I plugin in. It's very common. All plugins use this. So out are those interfaces, which is data coming out.
You know,
Like the plugins. So OpenFlow will have this service implemented. So if you look at OpenFlow, we'll have both out and in. It will be incoming dependency, out is out. So now let's look at the code. I'm inside this OpenFlow plugin. Right? Let's look at the inventory service. The inventory service, you see that I plugin inventory service is the interface it exposes. Right? Whenever a module exposes an interface, that means that someone is going to query you, someone is going to call you on the interface. So now, when you open this I plugin inventory service, you see that right? See that there are two functions here: get node props and get node character props. So basically, what says is in this incoming course, like any plugin here. So the inventory will have two of them, in and out.
This is the cell.
This cell. So cell is a place where we define these interfaces, and those interfaces are implemented by the plugin and the function models based on the patient property. Plugins typically implement the in service, meaning whenever say it's a topology manager, topology manager wants to know what was available on the so it's going to say sal inventory service dot get node props. Yes, Sal will not do anything. Sal is going to query the plugins underneath. It's going to say, hey plugin X, meaning OpenFlow plugin in this case, can you give me all the inventory that service you have? So we call it the plugin in service, plugin in inventory. So if you look at this OpenFlow on the, if you look at the activator.java, it's a place where we implement everything. In activator.java, every class will say what interface it exposes and what are the functionality it provides. So in this case, the OpenFlow's inventory service, the Java in OpenFlow, will implement an I plugin in service. I plugin in inventory. So when Sal calls inventory, it queries I plugin inventory dot get node props is cost. And that's from here. So now, this interaction provides two advantages. The topology manager here doesn't care about whether it's OpenFlow or any other plugin it is. All it's going to say is get node prop for all the plugins around your care. So now Sal will go plugin after plugin and collect the properties, not properties. So as an example, right, in Cisco we have
Just a question. Are you talking that a plugin instance attends one network element?
no. Plugin instance handles multiple.
But there's no replica of the information that has been obtained from the plugin.
Sal is stateless. Sal play is stateless. It's completely stateless. You can restart Sal without any problem. Right? State is maintained in the plugin and on the function models.
Which state is maintained in the plugin?
Everything is
Most is there. Okay, but state is maintained, but
I mean, state
we're not
of
seeing that.
State of
We're not seeing that. State, for example, the plugin maintains the state.
Yep.
So it maintains sockets, for example. Yep. It's one state. It's a very low level state. You know, high level states, inventory. It maintains inventory also. Meaning, if there are 5 devices connected to you, the plugin maintains 5 devices information. Okay.
Let's say I have 27 switches over there.
Yeah. So what happens is every plugin has different way to learn topology, right? In OpenFlow, we learn topology using LLDP. We send LLDP message, flow bit is sent in. So in Cisco we have OpenFlow and OpenPK, right? OpenPK is a mechanism where we don't learn topology using LLDP. Rather we use CDPs running on network. We say get neighbors and we give the neighbors. Right? So this topology discovery is per plugin specific meaning. So above Sal, nobody cares how we get into the topology.
So let's say this was OpenFlow. Who issues the LLDP
Here.
queries?
Here.
The plugin?
Plugin. In the plugin we are
So that means that the topology manager is comparing this to
No. The plugin is issuing the command, but it's reporting topology to the cell.
correct.
In a way
But I
that's
need
consistent across all plugins.
Yes,
But that means that if I add an OpenFlow plugin, then I need to understand everything that about the topology myself as a plugin. For OpenFlow devices that are connected to me.
I need to know the neighbor, or I need to be able to discover the neighbor information for that network element.
Right, but it could be a really big network, and so I need to.
I may have a lot of neighbors.
Not only names, like you may have hierarchies over there, and you need to be able to do that.
But is that
So you discover all that, and then you just throw it upstream and topology manager
But
does it.
that to me reads as, let's say I have 50 switches over there, I need to be able to describe to sub exactly
Yes.
Switches are organized.
Yes.
Which I call, excuse me for the limited language, I call this topology.
It's a graph. It's a graph.
It's a graph.
It's a graph. So today, the topology, it is a graph. It is built here, right? So
I think that makes sense. It's all protocol and implementation specific discovery. So you have you're the only guy that knows how to discover it. So you have to discover all of it that's in your domain and throw it upstream.
But that goes back to the conversation of the morning. As, so eventually, what you end up having is a collection of different devices. There isn't anything that is unifying. So what?
it is unifying. So I can give an example of my own experience in this one, right? Today we are implementing in Cisco two plugins. One is OpenFlow and one PK. We're doing it today, right? What we're doing is OpenFlow is going to give OpenFlow specific topology. One PK is going to give one PK. We merge them together. Okay? That's a very critical part. The critical part is
You merge them and log on them, or they are two separate?
both. So they're given
So
different.
let's say it's a graph, and some elements of the graph who's putting that graph together?
Topology manager who lives above that.
The idea is discovering topology. Discovering topology is specific to a given plugin.
Certificate triggered by itself, or do you trigger topology discovery?
Topology discovery is all plugins. Discovery is in plugins.
So it should be.
So independently discovers topology and this classes when it's varied by the topology.
It's both. So a topology manager can vary the topology using get edge props, or topology edge updates are given by the plugins towards the
It's not entirely true that the topology is from that particular plugin point of view. This is topology. It doesn't mean that it is the topology.
Yes, discovery. Let's say discovery. If you look at the code, you'll get difference. Discovery means those code which actually discovered by sending LD flow and so on. So discovery is specific to a plugin. The topology entire graph is
If it's LLDP, it's not specific to OpenFlow. So why would OpenFlow discover with LLDP whenever it is? Right? So maybe you can say I have LLDP plugin that is doing the topology discovery, but it's not limited to OpenFlow.
no. In an OpenFlow network, LLDP is inserted by the controller. It's a spoof LLDP. Okay? But in a non-OpenFlow network, right? Say for example on PK, it may not even support packet injection. Right? So we will use the topology discovered by the protocols. Any protocol, the OSP. I will say, alright, I don't care. So
That's why, but what I'm saying is that LLDP is not part of the OpenFlow.
it's not.
And that's why would you rely on OpenFlow plugins to give you the topology? So an OpenFlow plugin, all what it can give you, it can give you what nodes are there for the OpenFlow protocol. It has connection to each switch, but it doesn't. So there is LLDP application that may tunnel its own LLDP packet through that controller. It can force it, but it's not part of the control. Again, the database of the topology is not built by the plugin. It's built by LLDP app.
That's the difference, right? So now you're talking about an OpenFlow specific controller or OpenFlow specific app.
No, it's not OpenFlow specific app.
Of course, yes, because you see you're going to say packet out of an app towards the OpenFlow and going to what means the OpenFlow specific app. Because now you are probing the network. By doing the sending an LLDP, you are assuming that hey, higher is my
It
responsibility.
doesn't have to be OpenFlow. The same LLDP app can sit on top of any other infrastructure, that is not OpenFlow.
What is
Can
it?
insert those messages because what it is saying?
OSDB doesn't support packet injection. OSDB doesn't support packet injection. So one packet doesn't support packet
There are
injection.
those that support. There are those that don't
BGP
support.
doesn't support packet injection. PCM doesn't support packet injection. So what do you do with all this? So what I mean is the discovery part is specific to a given plugin. discovery part. But the topology as a whole,
Node discovery, not the topology. Node discovery part.
And links discovery. Node and link.
yes,
But not the topology discovery. There is a difference between link and node discovery and topology discovery.
They don't ever leave.
There is a difference.
No, but
I might derive some.
if you consider that it was a specific operation, I mean, leaving aside the so you mean that LLDP for security discovery is that's never dealt with by the topology method. It's only those. In other words, LLDP packets don't ever pass the SAL boundary.
no,
Yeah.
no.
Discovery really isn't driven above the SAL.
It's from the original plugin, goes out, comes back, consumes, okay, now I learned it. I know the open flow topology. Right? The plugin can know about its own topology, but not know about the neighboring.
So managing process for how that discovery is done is all done autonomously.
Yeah. So the only thing that goes from the plugin towards SAL level is the edge updates and port updates. What goes down, sensor. Edge goes down, sensor.
And discovery is perpetual. It's not an event, it's
Oh, it keeps happening.
Constantly.
It's constantly happening. Right? Because we keep probing, we keep sending the messages. That's overflow, right? On PK, what it does, we learn the CDP topology already learned in the network. Just go and say, hey, who's your neighbor? Look at the neighbor. That's who's your neighbor, look at the neighbor. And then you put together and then give the information back. So, discovering that topology is really up to the plugins. Okay? That's how it's done, right? And
Okay, as it is done today, that's fine. I disagree that it has to be done. Because I totally disagree with that. It's breaking the layers, you bring something that is totally irrelevant to a particular plugin. You may use that as a transfer if you want to inject, but
So-
not part of that.
can you explain me one thing, right? How are you going to put together BGP network on OpenFront? See, I have two data centers running OpenFlow on their edges, right? And I have a LAN talking about BGP LS, right? Can you tell me how do you want to learn topology? And who's going to learn it for you?
First of all, you have multiple topology discovery networks. Each one is from its own view. Okay? So you have BGP as its own mechanism discovery. OSPF will have another mechanism of discovery. LLDP will have another mechanism of discovery. And by the way, LLDP can use for that purpose either the open flow, and it will discover the open flow, or you can run actually LLDP on top of optical links and discover optical topology. You can do, but you can apply application.
LLDP is a layer 2 topology discovery, link topology discovery. It is not a layer 3 topology discovery. When they have BGP and MPLS, they are talking about layer 3 there.
I didn't say that it's not. It's different topologies discovered.
Yeah. So,
Okay.
based on the plugins, right? Now you're talking about plugins because now the moment you talk
No,
about
it's
others,
not about plugins. It doesn't matter what plugins they use. Right? You have multiple layer 2 topology, probably plugins. You have multiple layer 3. You have now BGP plugin
Yeah.
that is proposed.
Yes.
So who discovers the plugin or the application BGP? Depends where it runs. Now, what you want, and I disagree with that, to push all of that functionality into a plugin. By the way, as soon as I push functionality of discovery, topology discovery into plugin, what we discussed yesterday that it doesn't have any persistent storage bullshit because the topology you need to keep.
no.
You don't
Topology
want to go.
topology is a dynamic. Topology is a very dynamic entity. It's very ephemeral. Right? You don't
As
have
soon as you go
topology.
to it, it will take you forever.
Topology is Alright.
You can ask more. Yeah. I think the point of this technology is that the current state of the
Yes. How it's implemented, how it's done.
You can have a separate argument about whether it's wrong or right, but tell us what it is.
Okay, yeah. So, the implementation is explaining, right?
can go there, we should set it
So at least you know where to discuss. Now you know complete discuss on how to do double discuss. Alright. So implemented service here where every service has in and out. Where in means is coming in, go, right? And child is just a content function. We have inventory, we have topology, we have flow programmer, where again, it means we'll say, hey, go and add this flow, delete the flow, modify the flow. And if you look at the out, it's do something like flow was expired. It's even going towards the applications, the events going towards the plugins. So in and out.
So in the middle, it's not plugin specific, right?
Oh, this is salad.
This is out.
This is salad. So the way we differentiate which plugin that the information should go to is based on node, right? So every node, we have a entity called node. The node is not. It's like a data type. It's nothing. Node is made of node ID, node type, and node ID. Again, depending on the plugin, the node can be of different types. So in OpenFlow, node ID is long, maybe long. In another plugin can be a string value, right? So on and so forth. It's a unique identity of a given node in a given plugin. So, but
and in current implementation, the same node can be in the multiple plugins, or you assume that there's only one plugin owns the node.
Okay, to be very clear there, a node is an entity where you have a specific relationship with. So, the same device, for example, we can talk two protocols. Say, I can talk OpenFlow and OVSDB, for example.
So you treat that as two nodes?
Treat as two nodes, yes. But there's a mapping layer. There's a mapping there where we can map between two different protocols. Even though there are two different nodes, we can make it look like this. Right? There's a mapping there. But today, if a given node talks to different protocols, it's seen as two different nodes.
Is the assumption that the different protocols have access to different resources in the system?
That's right.
Yeah, sometimes they tend to be a control plane protocol and a protocol.
So it's a separation between nodes.
But there's a big, we have node mapping service where we can map multiple nodes to look like a single node. But it's all like,
but you still cannot share the same root.
we cannot.
You still assume that
We
nodes
cannot.
are separate.
It's quite useful in case where there's a single device, it's a WAN edge, right? We can talk about flow on the internal network and something else now. So we'll talk here is the OpenFlow here, right? So it's useful, pretty useful for us to know, hey, these two are the same node, so apply the algorithm based on based on. It's quite interesting.
Okay.
So nodes are so based on the node, so everybody comes to the cell, select the node, hey, this node means this protocol plugin and protocol takes up similarly, node connectors. Node connector is again similar to node.
Our application of top nodes, one of those, which one of those nodes is used?
It will not.
It will not.
Application will not know which node you're talking about. Application is obvious.
I probably will. And then
But if application wants, they can figure it out. They can query the node, say, hey, what type of node you are? OpenFlow node or OVS node, they can do it if they maybe they can.
we're going to get another key.
The node is extensible structure, right? I mean, it's
It is.
something you can
I'll just grab another key now.
define it.
Yes. If you look at any code, right? One exercise would be there's a protocol plugin got stuck, plugin. Look at that, it will be very clear where we define all the interfaces, we define even the node, right? How node is defined. So when the protocol plugin comes up in an activator, the first thing to do is define a node. Meaning you say, hey, my node type is stub, my value is a string. From there on, whenever it comes from me, we'll know exactly what plugin does.
When you say package, it's a whole distributed package. So that's used by the sound to amongst the direct the node.
Look into the type rather than we have an abstract way of doing it. If you look at the activator, I'll show it to you. It's very interesting because one thing you have to always realize in OSGI is everything is kind of service oriented. Okay, let's look at this activator. Because you see it.
So ideally, you'd be able to have I can write a class and so that where should
I think when you go to sleep, it disconnects because of wireless. Because you need to log in. It's actually logs in.
If it could be powered, it will not go away.
You think so?
Yeah.
There's a couple other cool concepts that I'm not sure responsibility in but I would like
Accurate
explicit cases where guys
confidence.
have a reference or no reference to something. So like that. Remember, I think I mentioned where are the actors, where are the standpoints, where are the references, and where are the no innovation. And so the references will give you a reasonable way to know where the active is so that you can forward positive references. Right? As opposed to doing some because the partitioning won't align where the hash is going to get keys. So the hash keys here is usually every one of these hashes every node will have to unlink. We want related information. So
I'm going to activate on Java.
Other objects are related to, and that should be distracted. So, for example, the porting table for a port should be located where the port is, not on some other database.
So there's that.
So you can always do it, like an interface, you have base devices and so on. What you just because this is just one. This is the database services. Database services is the service which provides you want to send a given packet from your application towards the network, or you want to extract a packet from the network towards your application. Right? You want to use the database service to get the information from. So again, as usual, we have the high plugin data packet services. This is the service provided by.
I'm not even actually talking yet about all characters.
I want them to mute. We can ask them to go to the next one.
We have such
Guys, mute. You have to let the turn the volume just slightly. So guys, like,
So Brent wants to mute you guys.
okay, we want the mute button. It's even better.
Alright, so here is the evident here. The plugin in is an interface provided by the service, the plugin. Plugin out is something is dependent on. This is CI is dependent on. This is a provider. Here, as you can see here, the properties. So in an OSGA model, we can say what kind of property that the service is bound to. So here, I'm saying that zoom one. Oh, is it? I don't know how to do that.
Do me a favor, just kill your VNC session.
Oh,
It's distracting me.
I get zoom. It's fine now?
Who's back?
I got used to it.
I'm trying to kill it. It's a game, that's it.
It's like a cat with a little light in it.
So you really want to do experience? I don't know how to do it.
It's not just, my vision is a little bit worse than yours.
I know. The problem is, I don't have that result. I don't know how to do it. Yeah, that's okay. What?
Just crunch it.
You know what? Let me see.
Is it increasing font size like control page up or something?
It works here?
Control plus.
Control plus.
Does it work here?
Try it.
Command plus.
Command plus?
It's not a plus. I can change the display. That's okay. Forget it. Alright. Sorry for that. So, as you can see here, this is important. So here we are stating that for this property, it is protocol plugin time of OpenFlow. So now I'm saying, if the SAL wants to send a packet out, the way we time these services are based on this. So if you want OpenFlow, send it to my service. This is the iPlugin provided by me. Okay. Now let's look at the SAL code. The SAL, we actually go to this protocol plugin time.
Sort of about jumping on the side because it goes into the next whole thing. The list stuff.
it's as an example. This was OSDB. OSDB does the same. So we register with OS client.
Yeah, anything like that, send it our way. We can get it sorted out. If it was part of our proactive, currently happening on the core briefings, and that was one of them.
Yes.
So it's
Overflow or any.
Yeah.
And you have to, when you run handle any other data package, basically write it to some, especially some of the example specific.
No, data packet services does not send the overflow packet up. It will send only the data packet is carried inside the plugin. Say overflow, that's two mechanisms, packeting mechanism. Packeting is a mechanism where when a data packet is hitting the network, it gets encapsulated in the overflow packet and sent to the overflow packet. Data packet service actually extracts the packet from packet and send it to the other. It's not overflow specific. Okay? So we're just saying, hey, I want to receive packet on this interface. Doesn't matter. Give me packet node is similar. You send any packet, not this overflow packet.
I'm just saying that the only package that sees where they are implementing one. There's no other data package.
Oh, that's ARP is an example. Right, ARP is an example where the ARP panel sits on top. Okay? ARP says, hey, I'm going to receive the ARP packets. Alright? You say then the ARP is
Where is that filtering done? Is it done to cell?
Which plugin receives our packets?
sorry. ARP panel.
But how does the app get? It comes up through our full plugin.
There are two things. Keep going. So, what to do is manage the controller. Controller is.
Chris, I'll contact you about new times. Next day or two.
I'm not here. You're gonna have to find another volunteer.
Peter? I'm on camera here. I refuse to mention it.
I'm gonna zoom in on you so I can get the head nod, right? Right, Peter? I'll contact you. Okay, good. I'm glad you're so willing to volunteer for me. I appreciate it. Yeah, and yeah, no is not an answer I'm taking. So we will see you. All right.
They need to be fringe benefits, I think.
Exactly.
Oh yeah.
I'm gonna point to that. Alright.
Alright. So, this is the file code where we actually do the database service. So, as you can see here, so this is the place where you get the protocol packet type, which is registering to you, and then put down appropriate concurrent. And at a later point of time, you do the get to know exactly this. You do a get type. This is when you know, hey, this node type is we get an instruction.
I still don't get the answer to what Chris was asking me. What handle are
Yeah, but this is our random. Let me go to the.
I think there's a confusion. I think maybe Anish is asking which plugin handles that packet, and we're talking about which type of packets.
So,
I mean, I thought it was an application.
it's application, yes. But application is the one who's going to take the app packets
Yeah.
and process them.
Okay, how does it get?
Yeah, I'll show you. So, the ARP, when the ARP bundle comes up, it registers to the database service. How you get this callback saying this is a database service you can register. Now, so this is transfer. So, this data packet is the call we call once you get the data packet in the ARP packet. How do you get this data packet? Is because you implement this I packet in service. I listen data packet. Right? The moment you listen to I listen data packet, it means you're listening on any data packet coming from the network. So now you're going to get all the packets, not just ARP. You're going to get everything, including IPv4, any packet. And it's your responsibility to filter it in ARP.
and
Okay. Yeah.
probably needs to be done.
That's what the messaging bus is all about, I guess. Right?
We are doing this thing down somewhere. Today, unfortunately, it's so this is data package right here. So here you can see we can look at the archive, right? And do the handling. Otherwise, we need to count.
So every packet in is going up to ARP handler, and if it's not an ARP, it gets dropped.
Correct. So that's how it's done today.
That's why we figured out that we needed the mux down
We need
below.
it. We need
Any other
it.
modules usually, right?
Sorry?
Any other?
Oh yeah, any other module. So we have two types of data packet handling here. Where we have serial and parallel. When you have a serial data handling, what it means is you can specify which modules must receive traffic before you. In a parallel, meaning anyone can drop before you and you are having that. The parallel one, I don't care if somebody drops, don't drop it instantly also, right? So there are two mechanisms there, but actually it's all named so far, right? Because everybody says all the traffic is not good now. So the reason it is okay so far is because we are kind of envisioning this as an proactive mode, where we don't expect to see data packets coming to the controller much, right? Rather we will pre-install those flows, so packets hitting your controller will be very minimal. Mostly control packets, not data packets, right? So it is okay when you're designing that way. But it's even in that sense, right? It's better to have a filtering somewhere down below to say, hey, I'm not interested in all the packages. Send me this packet.
I guess one thing I didn't understand before is that actually we could use this for something like the CS. We want to get packets from base switches, for example, and this would get everything. It's another module that is different.
Yeah. So our panel is very simple, right? We know generally our panels. Why am I saying that we can?
I thought the only data packets we're getting. I mean, I know we're getting ARP, and we're getting a lot of open flow packets and packaging.
So packaging or not is plugin specific.
Yeah.
All the care about is data packets. Whether it is packaging or whatever, the plugin is handling. So that's the SAL provides an abstraction. Right?
So in your OpenFlow model, the ARP handler first learns about a new host attachment, tells the host tracker.
Actually, okay, there's no in OpenFlow. There's no in Open plugin. There's no ARP handling, right? ARP handling is only as an application, not top.
Sure. Yeah. No, I understand.
Yeah.
Yeah.
And ARP handler is the one. Yes, it learns the host and it confirms the host tracker.
And then from that, you can go push the proactive rule so
That's
that
right.
you never see any
That's right.
misses.
That's right. That's the idea.
Yeah.
That's exactly the idea. Right? But no, even with all this, we will see data packets. We just cannot avoid that.
Yeah. Partly there's a race between the host tracker pushing the rule and the next packet coming through.
Right.
Yeah.
So, but we have some tricks we can play. In fact, the code is already in the repository. So we have a mode called proactive mode. If you turn on proactive mode on a given switch, we go and install two entries. One called the ARP punt and LD punt. Drop everything else. Okay. So by doing that, what I'm saying is drop any nodes into controller, not drop on the hardware, right? We're saying punt only ARP packets and LD packets. By doing that, we are really restricting the number of traffic coming to the
So to get admissions control for anybody who's going to get through has to come through host tracker and get a new
That's
rule
right.
push.
Only through control plane you can get install your traffic to it, not through data. So we have that mechanism today, but it's off by default. So that means by default you get all the traffic before.
When you serialize, basically, is that configuration time, or is it basically you specify in your class what order you want to basically get? Like if you do serial process in the config.
Oh, that's not configured. That's you can explain. Yes, you can specify it.
And so host is probably a little bit over descriptive in terms of what it is. Anything that ARPS gets tracked.
That's a problem. Yes. So today, it'll be funny to see that. For the open switch, it doesn't send any ARP packets, so it's clean. But the moment you have a mixture of OpenFlow and non-OpenFlow device, that will keep sending ARP packets, right? Full control will not even know, so it will start learning it as a host.
Yeah.
But there are mechanisms to solve that. So what we do today is we listen to LDP packets and CDP packets at the same port. Same port setting. Okay, we know this is a bogus one. We don't want to consume that. So a few things.
It's interesting to know everything that's attached to the network, but it's within that it's interesting to know who's a host, whatever that means.
We can learn more about the interesting. We can learn. So so the most important file according to me is the implementer. That's going to tell you exactly about what a given plugin does into it. So in this case, the protocol plugin OpenFlow has multiple services: topology service, inventory service, data packet service, read service, and flow monitoring. These are different services it provides. But one additional thing you would notice is there's one more called global implementation. So there are two types of implementation that we have: container implementation and global implementations. So container implementations are those services that is for a given container. So you guys know what's a container? Hopefully yes. Okay. So container is think about where if you want to have multiple controllers in the same controller, you can use containers. Where it's like standardization at a code level. So you can define a container stating this container has its properties, saying anything in 172, 21, 28 range belongs to this container. That's an example. Right? So based on the property, you can restrict some devices to be part of the given container. Okay. So the moment you do that, we logically group these services together for a given container. So that's if we go back, when I go back to the this function, right, the configure instance. As you can see here, there is a container name we will pass the function, and every service dependency is based on a container name. Meaning what we are doing here is we are stating that like given container is its own it's not the same address. We share address space, but think of it as a different address space altogether, different control from top to bottom, right? From the top, applications support containers, SaaS support containers, the protocol plugin support containers. So vertical line. All the modules can form group into the given container.
Just watch out, they're still running the same game.
It's all in the same game. But
and there is an explicit cell
it's the same cell. It's just the cell is their own layer, right? The services provided are instances of each one. Every container has an instance of one. Every container has an instance of a service.
So instead of having two plugins, independent plugins, each dealing with its own subset of nodes, you practically introduce inside a single plugin container. That's about the same effect would be if you do two plugins.
But okay, yes.
But the container could be across plugins.
It can run multiple also.
That's the point.
Container can be within a plugin or across plugins. Okay, so container can.
So that we understand containers. So you could potentially create containers to handle geographic parts of a network.
It can.
Or you could create containers to handle logical layers of the network.
Or different ownership.
Yeah. Let me go. So
you can set that through multi-tenancy basically right there.
That's fine.
I don't know if it would go all the way to multi-tenancy. That's an interesting question because that now you're splitting on logical lines.
Yeah.
So we have the guys, right?
It doesn't solve all the bugs. It provides a framework.
So a container can specify which devices belong to the container.
So we use the terminology logical device before because we could have two plugins that are really controlling the physical devices. So when you say devices, you mean logical devices.
Correct. Exactly. Yes. Thank you. It's not. So the container has this flexibility where we can hardcode it saying, hey, this device belongs to this container. Okay. This was one way of doing it, right? Or you can say that, okay, this device is shared with multiple guys. This port belongs to container 1, this port belongs to container 2, this port belongs to container 3, right? So the moment you do this one, right, you logically get one node per container. This being the only node is seen in container 2. This being the only node seen in container 3. Right, logically. So this is a multi-tenancy use case where you can have the same device shared multiple tenants.
He was asking, so in Dove, for example, we handle multi-tenancy at some higher layer, right, logically.
Yes.
We would use one container to handle as opposed to the
So the container supports it also. Today it's involves flow spec. Right? That's a high level concept where this given device, we don't care about which interface or ports or whatever. Right? In the container can say a flow spec. Flow spec can say that anything source IP address 10.1.1.0/24 belongs to a container. Okay? It's a high level concept. Or you can say that.
So those are like flow specs, so like traffic-based containers.
Yes, not traffic-based.
You can create an instance of a controller which is essentially handling a subset of flows from the network, right?
Yes,
12 tuple based.
Portable based.
Every communication between me and Chris is container 1. And every communication between you and Madhu is container 2.
Now, another
And
question.
treat that as a container.
Another question so that I understand containers. If we are communicating in container 1, does any other container have visibility?
No.
No. Okay.
You
Some separation.
So consider it as separate address space.
Yep.
Consider it, but it's not true here because look at the 1 JV. Okay, to answer the point, right? The way we are trying to vision this one is if somebody is interested in containers and we have clustering support, right? We can have one device dedicated, one controller dedicated to one container, other controller dedicated to another container. So you get container with address space isolation.
So this is all defined in the plugin.
No, it's defined across everywhere.
This is defined in the basic infrastructure.
It's everywhere.
But there is a question who defines that because if I want to do OpenDaylight and I want to have visibility to everything, and then Chris came in and decided he wants to create containers, then OpenDaylight has to live with whatever.
And still end up resources that
Exactly.
So,
Exactly right.
So who manages the key is container manager. This container manager is a component available which does all these tricks where it says, hey, which device contains belongs to which container.
So then that's exposed to the node.
Exposed everywhere, to the north and everywhere. Right? So the REST APIs, look at REST APIs, every single REST API has a container component. Every one of them.
So if it is related to container manager, let's say that you define the points, 10.1.1.0/24 is container 1. Now the same IP address appears in the 3 plugins. Totally different maybe in network coverage. But the same appears in the 3 plugins.
That's fine.
Now, so matching works. How do you define which one out of those 3 is actually 10.1.0?
Okay, this is the one. We're talking about a case where we have an overlapping policy.
Let's say for the container.
If you tie a container with overlapping policy, not allow you. It will say that, hey, the overlap policy, right, specify even granular one. For example, in this case, we said, I might have different network elements, part of different sizes, different containers. You will define that. Once you define that, this container 1 has device 1, 2, 3, and 10.1.1.24, that means, yeah, I know, right? Even the same address space at the flow spec level, at a granular level, you can see that they belong to different device operators. So it's a combination of flow spec and the low level details, like the port and device units.
Okay.
Yeah. So that's the container concept is across the block. If you look at the controller, it's everywhere from northbound to southbound.
Doesn't the host tracker have to be tenant and or container aware?
It is container. Every module, most of the module are container. Most, including SAL, protocol plugins, northbound.
So if you invent a new notion of multi-tenancy somewhere else, you miss that.
It works. The thing is, what they're saying is, I want to have only one container, but my application is going to divide further. Absolutely yes. Right? It's definitely possible, right? Because the application maintains all the multi-tenancy. It's perfectly fine.
Is there hierarchy of containers in this case?
No.
So
they don't have it. Today it's fine.
So it's the container manager that provides you with your data.
Because I know you could have containers of all open flow devices, and underneath you have another container that deals with our traffic, and another container.
If you want a hierarchical container, right? Today we don't have it, but we can mix this with flow wisely. Flow wisely is a mechanism where you can do a kind of slicing, right, at the lower layer. You can do that, but
anyway, that doesn't matter.
Today the code is not there. Okay. Today it's flat container. Right? The reason I went there is look at the code. Everywhere you see the containers.
Because a container, as far as I can tell, a container is a bit of a wrapper, so that the software inside doesn't even know what's in a container.
Yes. Something I don't know anything about it.
So it's just why I ask about that, because since it goes across almost the entire controller, I know that principles need to be probably enforced from the very beginning how we want to see that. So if we agree, all of us, that I know we need containers and we need only flat containers, that is okay. Otherwise, I would recommend to change the code now, because if after that we need to introduce something else, I know you need to rewrite almost the entire code.
I think as a fact we have what we have. If we need hierarchical containers, then let's do that.
Yes.
No, but it's better to do that before we have
going sooner is easier,
because you will need to change everything.
No, but that's the point. Right? Container is a wrapper, right?
Yes, that's a good point.
So I can still write all my code, and it doesn't know it's in a container.
Right.
From the code point of view, I agree. From the application point of view, from I know everything within the controller, from the
even in the controller. If you look at the code today, right? The containers are handled at the activate level, not at the business logic level. So at business logic level, we will not know whether you're running a container or not. So even if you want to do a hierarchical container, the code inside this will not change. The only change is being container manager. But that is the guy who is going to support hierarchical container, and that is the person who is going to allocate resources for every container. So if you want hierarchical support, there's no change on the controller code basis, only on the container manager. That's what we define the same.
Okay, if you assume that the container name includes all that encodes everything on the side,
if it's a unique identifier, it's fine. Yeah,
you can do it.
Alright, so there's a critical information that you receive from an activator. So if you look at most of the bundles, you'll have an activator with get implementations. Implementation means container implementation. Okay? Config instance means configure container instance. You'll also see global instance.
That is in the same Java. Okay.
Yeah. That's why activator Java is critical. Everything will be this will be okay. There's one more thing called get global implementation. Okay. So this sorry?
So give all of those global information basically.
Yes. So the global implementations is a special case chaos. Okay. Let's talk about an example. Right? Say there's an open flow device. Okay. Open flow device you want to slice into multiple containers, one device. Right? I have only one connection to it. Right? I cannot have multiple connections. So the TCP connection is handled in the global instance.
Yeah.
The access connection is handled in one instance, global instance. The message that is going out is sent from the global instance. Right? Yeah. The containers just get the abstract information after the message is being handled. Right? So that's one example. Another example is user management. User management is one thing, right? User management is authentication is done at the output level, right? That cannot be in a per container level. It has to be at a global level. Similarly, container manager. Container manager must be in a global container. It can't be in a per container level, right? So on and so forth. There are some services like this, or they do present in the global instance. So there are two things. One is global instance and default instance. So default instance means the default container, meaning all your business logic is running in default container. When you say global, it means it's a global instance where it doesn't belong to any container.
So one container is always created, the default container.
It's always created.
So you have, at the beginning, you have two instances, one global, one default container.
That's right. Global is not an instance of container, okay?
No, okay.
Global is
I call it instance, but I know.
Sure.
Let's say something.
It is
space. Global is a space.
Yeah, global is a space.
Okay. Yeah. You're right, it's a Java instance. But I don't want to call it in the same sentence as containers. Right?
Okay.
So if you look at this one, right, you'll see that the kind of services are a bit different here. Global implementation has the shim, you'll see all the shims here. Inventory service shim, topology service shim, data packet mux, demux, so on and so forth, right? There are very specific places where the packet is coming in. I want to determine which slice it has to go to. It will demux into the appropriate slice, right? There are very specific logic here. They don't affect the business logic that we know of. For example, topological discovery is not meant to be part of the global existing implementation. What global implementation does is traffic. We have only one connection, only one open flow connection, right? A packet comes in. So company has determined, hey, this packet has come in. I want to send it to a right container. I don't want to send it to the wrong container.
A question. Where does the container start? Is it in the plugin or is it on the interface to the cell?
It is at the plugin.
It's in the plugin. So the plugin itself
yes.
can have logics for each different container.
The same logic of not all containers, of course. Logic will not change.
Yeah, but I'm sort of thinking, okay, if for instance I have a plugin Southbound and I have some files I'm loading in because I have some extensions and things and so on and so forth, that can exist in one plugin, may not exist in another instance of that plugin for a different container, right?
But you can make it work that way, you can.
Yeah.
But if you look at the way that it's done here,
does it exist in one plugin or one container?
A container instance. Because that's
it depends. I can show it to you. Right? It's a good question because let's go back here. If you look at this the dependency and all the things, right? Mm-hmm. You get a container name right inside the instance.
Yes.
Here it's up to you to discover it. You can say container red, I want to do only firewall. Container blue, I want to do
my point is a little more that when I construct a plugin, I may construct a plugin with some configuration information, with some state information about how that plugin should run. So if I construct a plugin with a container, the information that I push down is going to be only visible to that container instance, right? So the next one I have, if I'm doing different things with different containers, then I'm probably going to want different behavior.
You won't see any of this.
No, so I just push it straight in through the constructor.
Yes.
Okay, so start with the default configuration, right? And then you have unique per container that you find
Yeah, but I'm sort of thinking if I construct a container to look after a subset of flows within my network, in which I'm going to put a specific type of configuration down the OpenFlow plugins, I want to do some fancy stuff for that.
Sure.
Then that's going to be instantiated in that instance, not in another instance somewhere else.
You can do that because the container name is coming through you from config instance.
Yeah.
You have the control. But if you look at across the code today, all the containers are treated equal.
Okay.
But a plugin can decide to do different.
So where does the container? No, because the container is going to be. But you still have a global connection.
Yes.
To an element.
That's right.
At what point does that connection then enter the container space?
That's exactly what this space is. So you look at this. You look at the configure global instances.
Yeah.
You see all the shim and demux and everything.
Yeah.
These are the guys who actually does the demux, shimming and send to the appropriate containers.
Okay.
So initially, you look at the core.
So everything is coming to the global.
And
it's actually max demux, which goes to the right container.
Yeah. So the controller of Java, the controller of us, he's the one who opens the TCP connection, open flow connection. This is the way, right? The message comes in, it says, oh, it's a discovery packet or data packet, it's a data packet demux. The data demux says, I want to see what IP address this is coming from. IP address belongs to slice 1 or container 1 is to container 1. So all these guys, right? All these guys are the gatekeepers for which container is going to go.
How do you perform the call from the global to a specific container? Because they should be separated, right?
Yes, that's okay. Let me show you. Look at data packet demux class. Let's go data packet demux. It's easy. Okay. Here. Receive is a good example, right? So I get a receive packet on a given switch on a given message, right? Now,
that's global instance, yeah.
This is the global instance.
Global. Okay.
From here, you can extract out and send to the appropriate instance.
So you're checking and calling to a particular instance.
Correct.
Because this is on our
So what I'm saying is, these guys, right, the one I was showing you on the get global instance implementation, are the classes which actually does the demux for you on operating slice. So they will just determine which packet goes to which slice, which event goes to which slice. Whether you want to go to everyone to go to them.
Okay, we're iterating through.
Do we have any protection across instances, by the way, right now, or there is no data protection? Meaning how well those containers are separated.
Oh yeah.
Can one
They're not in the same
container kill another? They are in the same space.
Same data space is the problem, right? As I explained, right? The best way to, if you want full isolation, run every I can have clustering enabled with nodes connect to the appropriate
No,
container.
if you go to physical nodes, I agree. But within the same physical node,
that's the problem. Yeah, we don't dedicate some cores to a given container. We don't do that. It's all shared space. It's a quad core CPU, right? All cores will be used by all containers. We don't dedicate 2 cores to a given container.
Can we separate by Java instances somehow? The memory.
Today is only one. Today we have one JVM. That's it. 1 GB.
Okay.
So we share the same data space.
So the IDATA packet listing is actually the array of containers that are listed here.
Correct.
Okay.
So the way, if you want to look at this one, right? Always look at this function here. Set and
So I have a question then, because this is just been iterated through, and then you're expecting the container itself to identify whether it wants to do it.
That's right.
And then you're stopping at the first one that mentions.
It depends on what kind of data packet you want. The parallel instance, we need to all of them parallel. And the serial guy, then we stop it with this stop.
Okay, so it's
That's defined per packet type. Where do you decide what's parallel, what's serial?
It's today, look at the way we define it. It's based on a given module. Modules is having parallel serial. It's not per packet type.
Okay.
It's module dependent. Whichever module says, hey, I'm interested in this packet, it'll say, okay, I'm a serial guy or parallel guy. Should we move on?
Yeah, I'm just trying to come back to look. I'm missing function. It's okay.
So, to me, the best way to look at the code is to hack it.
Run it.
That's it's very difficult to understand otherwise, really. It's all abstract.
no, but at least I know you give us information how to get into that.
Yeah. So the way
The main point is where to enter.
Yeah. And we use look at the OSGI service registry, which is I think it's using a LDAP inputs. I don't know what which one is used. You see code like this, right? Name equal controller. It's all LDAP specific. We have any code. So here we are filtering a given service dependency, saying if the name is controller, then you can't do it. So that's how we use LDAP.
Sorry, the name is controller.
So here, you see here, right?
The next few.
This is LDAP. All it's saying is you set this instance of this controller icon with as only if the name is controller. The name is foo, it not get registered. It's very critical. If you look at a lot of code, right, you will see we use it extensively on how to mux and demux information. Right. So this actually, if you look at the code, it's very raw way of writing code. Very raw. If you look at floodlight, if you look at any other OSGI implementation, they all use something called declarative services, DS. Declarative services is based on XMLs, right? Easy to define. Right? If you go to XML, define it, it's easy to define. But the problem is with XML, the declarative service doesn't support the container concept. Container is very dynamic in nature, right? I'll be able to fuse one instance to another instance of the container and then keep fusing them the way you want to do it. But declarative we are not able to do that. That's why we were actually using declarative before. Very simple to define, go to the XML define it to get fused. But when you introduce container, it never worked. So we changed the entire code to go with the hard coding code. That's why because the code here, it's all nasty. We will always have this class names defined and with all, right? So it's nasty because the declarations were hiding it for you before in XML format, XML format. Now it's all exposed in the raw format. So don't get, if you get used to it, a couple of times then you won't mind it. But first time you see, it will be jarring. Hey, why are you guys using class files directly in a function? Yeah.
Which is not very good.
It's not really at all.
Maybe we need to find somebody.
Yeah.
No problem. Yeah.
It is ugly. It's extremely ugly. I'm saying it's extremely ugly. We didn't find any other option. So we went through various technologies. In fact, somebody asked me a question once, why we use Apache Felix VM for this one? We didn't have a choice. Equinox DS doesn't support, cannot support containers.
So complaining that it's ugly is the same as volunteering to fix it.
That's right.
It's beautiful.
I think it's beautiful.
That's a good point.
That is called bullying.
So,
We don't do that in the open community.
okay, so pretty much if you start with activator.java and any of the bundles, you will get the full spectrum of view of what this module really is. When you know that, you can go into specific, for example, now you can go into prototype device, you understand what it does. You saw that this is a DNS specific to global containers. We know immediately that this has nothing to do with containers, it has a different role to play. Now look at the code and really see and understand what is going on. And one more thing I forgot to mention is this one. The callbacks. It's critical. Whenever you have a service dependency like c.add, we are saying I am dependent on iController.class. And one more important point is all of the interfaces here. You won't see a direct implementation being directly fused to it. Right? I'm saying I'm dependent on interface iController.class. It does not know what is the actual implementation. It can be different anywhere. Any person can do it. This interface. So iController.class happen to be implemented by controller.java. Right? But if you want to replace this, you can replace it with any other implementation of your choice. And whenever, since it's OSGA, right, where bundle can come and go, so OSGA takes care of the dependency management. So for example, SAL comes first, right? The plugin comes later. Right? It's fine. What if the plugin comes first and SAL is rebooted, right? If you reboot the SAL, then since everybody is rebooting on SAL, then everybody will go down, right? So the way it's done here is, any dependency is mapped in the OSGA Equinox. Based on the dependency is being expressed on this files. Right here I'm saying I am dependent on iController.class. Right? So I am dependent on iService. This. So look at this service listener. Let's go to this one. iOS. Okay. I have to program them. Right? So I am plugin for out service. This is it belongs to SAL. Right? So now if I want to know when the SAL comes up and goes down, it's based on these callbacks. So your bundle won't be called, your bundle start won't be called until all the dependencies are serviced. It's a critical one. So if we are at a Java file today, right? The first thing you write is public static void main, right? Write a main class, write a code work for you. In an OSGA environment, the one you want to is start. So if you go to the start function, let's go to flow programmer and service. Everything will have a start function. All the callbacks, set callbacks, right? Only after all the set callbacks are called, we start to be in that style, right?
So if SAL fails, plugins would fail.
Yes, plugin will be sent to a state called the resolve state. Resolve state, meaning it will not be active. It will be frozen.
They don't fail. They just go into inactive state, waiting for all the callbacks.
Dependencies to be
getting out of commission. So let's say I have a network event at this exact moment, and I have a plugin.
Nothing will process.
Exactly. That's the
correct.
problem.
So if SAL goes down, it's not SAL. It's a dependency chain, right? If it's like a tree, right? If the root is cut, everyone must fall down, of course. So, but if the leaf falls down, doesn't matter, right? The tree can survive. So if our partner goes down, nobody cares. Only cares about the host target. Host target will go in a frozen state, dissolved state.
Oh,
But
I thought the model is that we maintain state in the plugin. So I'd like to.
No. I don't think the intention there is that we're maintaining state in the plugin. I think what the intention was with the whole LLDP thing was that the plugin is responsible for identifying who the neighbors are, and therefore it needs an LLDP function. At least it's implemented in such that it's using an LLDP function to provide that to the cell. It's not that we're maintaining a lot of state there; it's just an engine.
Well, there's no state other place.
Well, obviously there's some states. You can't have an engine.
no, actually states are all maintained above cell. It's all maintained above cell.
Above cell.
It's
Topology manager keeps all the topology state.
Maintains states.
The only thing the plugin's doing is getting the information. So it's pinging the network sending step up, and sending it up.
Well,
And if you unload it and reload it, it learns it all again.
Yep.
It doesn't preclude me as a plugin owner from saying that I want to keep the my topology current all the time.
Yes.
You're not dictating to me that I should not.
Yes.
Yeah, we're just saying
So a model like that would have an issue if something in the center stops working for some time and now my model became non-current.
Correct.
So
I want to keep that model.
Right, we're just trying to.
I'm just trying to understand what we have here. I'm not suggesting go here or there.
Right.
I'm just
So
trying.
yes, you'll have lots of state, but no, we prefer you didn't persist it.
So the way we are trying, the way we implement the choice.
Yeah.
So if you look at the code today, the SAL and below, right? They are, even though this maintained state is not a state that you can persist. It can be, can always run anytime, really, right? That's why the clustering services are not hooked to these plugins. Clustering is only done above SAL because hey, states are synchronized. They are always current. Everything is done. Plugin goes down. Who cares? We are doing everything back, right? And it works fine. It works reasonably well and keeps the code less complex. You know? It's already complex, but less complex. So yeah. So one thing is guaranteed is your start will be called only after dependency service. Destroy will be called only when you want to kill your module. And init is called before the.
When you go to inactive state, start is called again after that?
Yes. When you come back to start, you start will call. So and everything else is a function call. So if you look at anything else in the code, it's a function call away. So here we have add, what we add. So all like you can look at the code to figure out what it is. How do I have to go through the function will application. What? I want to stop here. Let me see if there are any questions on any of this.
No, I'm just putting things together in my mind. I mean, the way I see it, we're building a plugin. We're proposing a plugin application where we're able to work with a number of versions of OpenDaylight and expose those to SAL. So from that perspective, my basic connection handling, my node identification and protocol negotiation is a global function. And then I have a choice of either instantiating my libraries for that global connection there, or I can instantiate the globals within a context so that I can tune it depending on container. And so I can actually instantiate those libraries within a container so that I can tune them with configuration.
How do you define in our case containers within or across separate versions of architecture? Who decides that? Who decides that? How you build containers? So let's say that you have 3 versions of OpenDaylight.
Yeah.
Okay. I know
the versions of OpenDaylight are kind of irrelevant, but
so you have 1.0, 1.3.2.0.
And you want to have
each one has a container.
But then you go okay. So then I have a controller which is managing my 1.0 elements, a controller which is managing my 1.3 elements, and a controller which is managing 1.5 elements. And I certainly hope that the network underneath isn't heterogeneous, or I'm going to have different controllers for different parts of the network, and that's going to take a lot of east-west.
I'm just thinking how that container manager or whatever is configured or processed. What is the container? how that is defined.
I think it's easiest to just work as though we have well, no one can do that because then you're actually assigning a controller to handle a specific element in the network because it's the element that's exposed in the protocol version. And if you kind of have those segregated nicely into AS-like divisions, then the controllers are
let's say that I'm talking to Chris and he's running OpenFlow 1 and I'm running OpenFlow 2.
We can be running
and we want to be in the same container because it's our session between us, right? And it should be perfectly okay. Now, my only question is how all that is, provisioned or discovered by the container manager. How we define those.
I think I understand it, but I'm not explaining. We would essentially construct a container that is matching the tuples which are just going to construct every flow that's occurring between us. And that container would instantiate everything the controller has, up to the point where you have the global, which is what's actually talking to the boxes in between us.
So protocol independent, that protocol agnostic, whatever it comes on the bottom, what we said after connection manager. So connection manager belongs to the global.
Wait. My cell, which I have here, needs to know what versions of protocol is being discussed with each of the cells between us. Right? Because my cell is still maintaining the quality of this very, very business class methodology. We don't know where
my question was, that I understand, my question was, connection manager is container dependent or connection manager is container independent? How do you treat, for example, connection manager?
Yeah, the connection manager,
is it within the container?
No,
that's global?
And then you can either choose to, and we need to have a discussion around this, either instantiate your protocol handler as global or as
because you could have multiple you can containerize also connection manager in general. But the question whether it makes sense or not.
The actual connection has to be global. But how much of the connection manager you want to containerize there is
by the already connection manager. I'm writing a common connection manager.
Oh, you are?
I'm writing it right now. I'm part of the UI.
Okay.
So I don't know if you guys are talking about the same or not, but is this
okay, then the connection manager is the issue because we
need something like that.
We need something like that.
Oh, perfect. I'm writing it already.
Okay.
So the idea of connection manager is running above SAN. It's not on the plugins. Running above SAN.
Okay, we're talking about different things. Okay, you're talking about network connections. We're talking about
no. I'm managing connections.
Okay, you're writing a manager for element connectivity above the SAN.
Above SAN. The TCP states are maintained in the plugins, but what it does is these plugins ask SAL whether hey, should they connect there or not. Right?
The authorization. That's what you mean.
There is mechanism, right?
Okay.
We want to keep it above SAL because module control can be used across.
Yeah. No. I understand that. Yeah. We see that as a configuration function pushed down the plugin, right? So I guess you're writing the connection manager isn't really looking at the actual implementation of the connection. It's looking at.
Somebody provides, where's the database that defines all those connections? I don't care. But somebody gives that database or that data store and say, you need to connect to those three. Okay? Now, and that is given to the, and then I'm starting a SSL session on those three.
So I just started it. This is not completely.
I need to read the blurb.
Take care. Take as many as you like.
Take care, guys. I'm out. See you all next time.
Yep.
No, this is a bit. So we have multiple schemes. So that's the logic of it, right? We can say container scheme where a given container will be part of a given control. Meaning container X has node 1, 2, 3. You can say this node 1, 2, 3 container control. If somebody not hacked, I'll say no, I'll accept it. So now this has various schemes, and you can say which is connected to you, which is not.
Some other cool things like
you can do, and it's connected. You can connect to a given device using identifiers, some properties.
The known devices, right?
Known devices you can connect to, right? If the unknown device, like open flow
connection exactly.
when it connects to us, so there is I wrote one callback.
Chris, I'm heading off. I'll shoot you an email.
Do so. Because I actually want to have a meetup next week. We probably involved in the meetup next week. How we're building this thing, what interaction, especially since you're a local competition.
Yeah, so we all neighbors.
Okay, do so.
5 minutes from each other.
I think that would be very good in the Bay Area.
Yeah.
We'll have the
Next week, yeah.
And one more thing, this is the important one.
I always want to do a WebEx content where we record it. But that's a little
Sure, yeah. That's
And I wrote a bunch of code. In fact, we use this for today for the OSDB.
Yep.
So we are connection listener here. The connection listener, what it does is today we support only one API here. It says this connection all of right?
Okay, yep.
So now when the OpenFlow connects to the plugin asks the connection manager to saying, hey, should I power it or not?
Yeah.
Now it's passed to this.
Yeah.
Now the police kind of.
It's a
very simple one, but I mean, we need a little more than just
We need more than that.
So the reason I put above SAL is for the reason that I want to across plugins.
So this is exactly the sort of thing that we're thinking, because from our perspective, we want an interface at the cell level that we can call. We got a node is allowed to talk to us.
That's right.
And we should also be able to state, well, we're not going to be able to state what context, what container it's in.
Yeah.
At that point in time, exactly. We would probably be told then that it's either going to be within this container or we don't care.
I just want to do this. I keep doing this on the container manager.
Yeah.
The logic of maintaining it.
Okay.
The agents will just ask.
Okay, so it's pretty much a global function then.
It is global.
We're allowed or we're not allowed. Okay. Good. Yep.
And this is the query part, and the connection part is actually also it is defined in the connection part. All these schemes and what are the nodes available, what are the broken nodes, connect based on clustering. So here we are clustering hookup. So you can even say this location, right, this part of this network must connect with these devices. So an India device tries to connect to US and say no, I can't connect to you. You go back to your control, the cluster control.
Yep.
So now we can logically take an OpenFlow device.
Yep.
Say I will not accept connection here, but I'll accept connection there. So if you have HA control on your OpenFlow device,
yep.
you will always get a master that's closer to you.
So you can direct where the connection occurs, and you can also direct where the redundant connection in one of the clusters will be.
Can you redirect it, or you're saying
we can redirect. If you say I reject it, you'll connect to the next one. So since we have clustering enabled on the connection manager, they all know exactly who is the master for a given node, and they'll take over.
good, guys. Thank you very much.
It works fine. Now, I'm trying to
Thank you. Good to meet you. See you next week. See you again. Thank you.
But this is good.
Thank you. All right. Have a good one.
Yeah.
We're about to begin over here.
Okay, Southbound plugins. Have a good one.
Alright, take one. It's fine.
This is for scaling the system. What is your
I was expecting
one server?
any module it's exactly the same. Just all the plugin on the SAL and exactly the same as the exact same thing. What makes it a Southbound plugin are not those interfaces that that really makes it a total plugin. Right? Now let's take an example of protocol plugins over
It doesn't make a difference. If you show me what needs to happen.
So one of the very first things that really makes it a plugin or any module is activated in Java. If you look at activated in Java, this typically means an internal process. The activated is volume supporting your module. So let's start from implementations. So there are two functions called get implementations and configure. these two functions expose what a given module does, what it depends on, what it exposes. Now, inputs are those class files which directly interact with other class files or other modules. Topology service here, we see a corresponding topology service in config engines, so on and so forth. Now, we see that topology service is a class inside OpenFlow plugin which exposes I plugin topology service and I topology service insertion. So, when you go to the board, we explain a small thing, then make it but what each All is stateless. Start is stateless. It's completely stateless. You can restart Shell without any problem. Right? State is maintained in the plugin and on the function groups.
Which state is maintained in the plugin?
Everything is
most is there. But state is maintained, but
state
we're not seeing that. State, for example, the plugin maintains the state. It maintains sockets, for example. That's one state. It's a very low level state. You know, high level states. Inventory. It maintains inventory also. If there are 5 devices connected to you, the plugin maintains 5 devices information. Yeah. So what happens is every plugin has different way to learn topology, right? In OpenFlow, we learn topology using LLDP. We send LLDP message, flow bit and send it. So in Cisco we have OpenFlow and OpenPK, right? OpenPK is a mechanism where you don't learn topology using LLDP. Rather we use CDPs running on network. We say get neighbors and we give the neighbors. Right? So this topology discovery is per plugin specific meaning. So above cell nobody cares how we get into the topology.
So let's say this was OpenFlow. What issues there will be
here.
Where is
Here.
Plugin.
So the plugin we are.
So the topology manager is completely
No. The plugin is issuing the command, but it's reporting topology to the cell.
Correct.
In a way
But
that's
I need
consistent across all plugins.
Yes,
But that means that if I add an OpenFlow plugin, then I need to understand everything that about the topology myself as a plugin. For OpenFlow devices that are connected to me.
I need to know the neighbor, or I need to be able to discover the neighbor information for that endpoint.
Right, but it could be a really big network, and so I need to.
I may have a lot of neighbors.
Not only names, you may have hierarchies over there, and you need to be able to do that.
But is that
So you discover all that, and then you just throw it upstream in Topology Manager.
But that to me reads as, let's say I have 50 switches over there, I need to be able to describe to sub exactly how those switches are organized.
Yes.
Which I call, excuse me for the limited language, I call this topology.
It's a graph. It's a graph. So today, we open this plugin inventory service. You see that? Right? See that? There are two functions here. Get node props and get node character props. So basically what says is any in this incoming towards the plugin. Any plugin here. So the inventory will have two of them. In and out.
This is the cell that
this cell. So cell is a place where we define the interfaces. And those interfaces are implemented by the plugin and the function groups based on the patient property. Plugins typically implement the in service. Meaning, whenever, say, it's a topology manager, topology manager wants to know what was this available on the so it's going to say sal inventory service dot get node props. The sal will not do anything. Sal is going to query the plugins underneath. It's going to say, hey plugin X, meaning OpenFlow plugin in this case, can you give me all the inventory that this service you have? So we call it the plugin in service, plugin in inventory. So if you look at this OpenFlow on the, if you look at the activator.java, it's a place where we implement everything. natively in Java, every class will say what interface it exposes and what are the functionality it provides. So in this case, the OpenFlow's inventory service, the Java in OpenFlow, will implement an iPlugin in service. iPlugin in inventory. So when Sal calls inventory, it queries iPlugin inventory .get no props is cost. And that's weird. So now, this interaction provides two advantages. The topology manager here doesn't care about whether it's OpenFlow or any other plugin it is. All it's going to say is get more prop for all the plugins around your care. So now Sal will go plugin after plugin and collects the properties, not properties. So as an example, right, in Cisco we have
just a question. Are you talking that a plugin instance attends one network element?
No. Plugin instance handles multiple.
But there's no replica of the information that has been obtained from the plugin.
SAL topology,
I think that makes sense. It's all protocol and implementation specific discovery. So you're the only guy that knows how to discover it, so you have to discover all of it that's in your domain and throw it upstream.
But that goes back to the conversation of the morning. So eventually what you end up having is a collection of different devices. There isn't anything that is unifying. So what?
It is unified. So I can give an example of my own experience in this one, right? Today we are implementing in Cisco two plugins. One is OpenFlow, one week. We're doing it today, right? What we're doing is OpenFlow is going to give OpenFlow specific topology. One page is going to give only topology. We merge them. Okay? That's a very critical part. The critical part is
you merge them and allow you on them, or they are two separate.
Both. So they're given different.
Let's say it's a graph, and some element of the graph who's putting that graph together?
Topology manager who lives above that.
The idea is discovering topology. Discovering topology is specific to a given plugin.
But this can be triggered by itself, or do you trigger components?
Topology discovery is all plugins. Discovery is in plugins. So it should be.
So independently discovers topology and just classes when it's very by the topology?
It's both. So a topology manager can query the topology using get edge props, or topology edge objects are given by the plugins towards the
It's not entirely true with the topology. From that particular plugin point of view, this is topology. It doesn't mean that it is the topology.
Yes, discovery. Let's say discovery. If you look at the code, you'll be a difference. Discovery means those code which actually discovered by sending LD row and so on. So discovery is specific to a plugin. The topology entire graph is.
If it's LLDP, it's not specific to Open. Usually, so why would OpenFlow discover with the LLDP whenever it is? Right? So maybe you can say that I have LLDP.
It's fine. It's not easy.
Okay.
I can handle that, but I can handle that. I'm not saying that.
Okay. So, SAL is very, very convenient. SAL is, in fact, SAL has no business. SAL provides this. It provides the APIs on both the northbound and southbound. So SAL is a very thin medium. So whenever you see in every service, today SAL provides 6 services. Divided into both. So there will be 8 services. First, like the service.
I'll defer.
Discovery service. Topology service. Program service. Any model running on top, we call it the FRM application. The topology analysis, UI application, so on. All these applications involved all talk this service, which is the out. So every plugin, every service will have two interfaces. An out interface, so you can see I plugin out, I plugin in. It's very common. All plugins will see service. So how are those interfaces, which is data coming out, like the plugins will have this services implemented. So if you look at OpenFlow, we'll have both out and in. It will be incoming dependency, out is out. So now let's look at the code. I'm inside this OpenFlow plugin. Right? Let's look at the inventory service. The inventory service, you see that I plug in inventory service is the interface that exposes. Right? Whenever a module exposes an interface, that means that someone is going to query you, someone is going to call you on the interface. So now